Somewhere in the small Magellanic Cloud, about 200,000 light-years from Earth, there is a star called HV2112. To any telescope, it looks ordinary, a red supergiant, old, bloated, dying slowly the way big stars do. But in 2014, astronomers noticed something wrong with it. Its light carried chemical fingerprints that shouldn't exist, elements in quantities no normal star can produce, as if the star's furnace was running on rules physics never agreed to. And there was one explanation that fit, an idea proposed 40 years earlier, so strange that even the physicists who came up with it weren't sure the universe would allow it. The theory says HV2112 isn't one star, it's two. Somewhere beneath that glowing red surface, buried deep in the heart of a living star, is the crushed corpse of a dead one, a star with a skeleton inside it. Tonight, we're going hunting for the rarest objects in the universe. The year is 1975. Kip Thorne, yes, that Kip Thorne, the physicist who would later win a Nobel Prize for detecting gravitational waves and who helped design the black hole in Interstellar, is working with a young astronomer named Anna Żytkow, and they're asking a question that sounds like a child's riddle. What happens if you drop a dead star into a living one? Now, to understand why that question matters, you need to know what a neutron star is, because it's arguably the most extreme object in the universe that isn't a black hole. When a massive star dies, its core collapses. Gravity wins so completely that protons and electrons are crushed together, squeezed into a ball of almost pure neutrons, about 20 kilometers wide. The size of a city, the mass of the sun. 1 teaspoon of it would weigh 1 billion tons. Neutron stars are corpses, stellar remnants. Their story is supposed to be over, but Thorne and Żytkow realized something. Stars are rarely alone. Most massive stars come in pairs, binary systems, 2 suns orbiting each other for millions of years. So imagine this. One star dies first, collapses into a neutron star, and keeps orbiting its partner. Then the partner begins to die too. It swells into a red supergiant, expanding hundreds of times its original size, growing, reaching outward, until one day it swallows its companion whole. The neutron star doesn't get vaporized, it doesn't bounce off, it spirals inward, ploughing through the living star's atmosphere like a cannonball through fog, and settles into the core. The result is a hybrid, a living star with a dead heart. Astronomers named it after its inventors, a Thorne Żytkow Object, a TZO. And here's the unsettling part. From the outside, it looks almost exactly like a normal red supergiant, which means there could be TZOs scattered across our sky right now, and we'd have no idea. So what is life like inside a Thorne Żytkow object? In a normal star, everything runs on nuclear fusion. Hydrogen fuses into helium in the core, releasing energy, and that energy pushes outward, holding the star up against its own gravity. It's a truce that lasts billions of years. But a TZO doesn't play by those rules. At its center sits the neutron star, an object so dense that its surface gravity is 100 billion times stronger than Earth's. The living star's gas doesn't just fall onto it, it screams down onto it, accelerating to nearly half the speed of light before impact. And when matter hits a neutron star's surface, it doesn't burn like fuel, it detonates. The gas at the boundary is heated to temperatures found nowhere else in the universe, not in supernovae, not in the cores of the largest stars, close to 1 billion degrees. And in that furnace, something remarkable happens, something with a wonderfully villainous name, Ordinary stars build heavy elements slowly, over millions of years, one careful fusion reaction at a time. A TZO doesn't have that kind of patience. In its billion-degree inferno, atomic nuclei are force-fed protons faster than they can react, then violently dredged up and yanked away from the heat by churning convection currents before the reactions can finish. The result? The TZO manufactures a bizarre cocktail of elements that normal stars essentially cannot make. Unusual amounts of lithium, rubidium, molybdenum. Remember those. They matter later. Because here's the thing about a disguise, it's never perfect. A TZO looks like a red supergiant. It shines like a red supergiant. But its chemistry is wrong. Those exotic elements get carried up to the surface and stamped into its starlight like a forged passport with one misspelled word. And that misspelling is the only way we can catch one. Oh, and one more thing about the inside. The neutron star at the center. It's not just sitting there, it's feeding. Slowly, over thousands of years, gas rains down onto it, and the dead star grows heavier. Neutron stars have a weight limit. Push one past roughly 2 to 3 times the mass of the Sun, and it collapses again into a black hole. Which means every TZO is a countdown, a star quietly digesting itself, hiding a corpse that is slowly, patiently transforming into something even darker. We'll come back to that. For nearly 40 years, Thorne Żytkow Objects existed only on paper, a beautiful theory with zero evidence. The problem is the disguise. The Milky Way contains thousands of red supergiants. Finding a TZO means checking them one by one, reading the fine print of their starlight, hunting for that forged passport. Enter Emily Levesque. In the early 2010s, Levesque, one of the world's leading experts on red supergiants, teamed up with Anna Żytkow herself and went hunting. They pointed telescopes in Chile at dozens of red supergiants in the Magellanic Clouds, tearing each star's light apart into a spectrum, looking for chemical anomalies. Star after star came back normal, normal, normal. And then HV 2112. Excess lithium, excess rubidium, excess molybdenum. The exact fingerprint, the precise cocktail that Thorne and Żytkow's theory had predicted decades earlier. When the results came in, one of the astronomers on the team reportedly said the star looked so strange. They didn't know what it was, only that it was something nobody had ever seen before. Headlines around the world announced it. The first Thorne Żytkow object may have been found. Anna Żytkow had waited 39 years to see her impossible star become real. But science is cruel to beautiful stories, because other astronomers looked closer. And doubts crept in. Some studies suggested HV 2112 might not even be a supergiant at all, that it could be a smaller, closer star with quirky chemistry. Others found the anomalies less dramatic than first reported. In 2018, a rival analysis argued another star, HV 11417, might actually be the better TZO candidate. Then, in 2025, new research delivered a genuine twist. Analysis suggested HV 2112 may not be powered by a neutron star core at all, but by something else exotic, hiding inside a star. So where does that leave us? With one of the most tantalizing open cases in modern astronomy. HV 2112 is either the first confirmed member of an entirely new class of star, or the universe's greatest imposter. And honestly, both answers are fascinating. You might be thinking, okay, weird star, cool story. Why should anyone care? 3 reasons. Think about it. We know of stars powered by fusion. We know of dead remnants, white dwarfs, neutron stars, black holes. A TZO is neither. It's a star powered largely by gravity itself, by the sheer violence of matter falling onto a neutron star. If confirmed, it's not just a new type of star. It's a new answer to the question, how can the universe make light? The atoms in your body were forged in stars, you've heard that before, but some of the universe's rarer isotopes have origin stories we still can't fully explain. TZOs with their interrupted rapid proton process might be a missing piece of that puzzle. There may be atoms on Earth right now that were cooked inside a star with a corpse in its chest. Remember that feeding neutron star? Astronomers believe that when a TZO's core finally collapses into a black hole, the star's envelope may come crashing down after it, potentially triggering an explosion or simply a vanishing. Some models suggest a TZO's death could look like a star quietly disappearing from the sky. And here's a chilling thought. Astronomers have actually catalogued stars that seem to have vanished. Surveys comparing old sky photographs to new ones have found points of light that were there decades ago and simply aren't anymore. Most have mundane explanations, but some don't. Were any of them TZOs finishing their transformation? Stars swallowing their own skeletons and folding themselves out of the visible universe? We don't know. That's the honest, thrilling answer to most questions about Thorne Żytkow objects. We don't know yet. There's a lesson buried inside this story, and it's not really about neutron stars. For 40 years, Thorne Żytkow objects were dismissed as a curiosity. Too rare, too strange, too hard to find. Estimates suggest that even now only a handful, maybe a few dozen, exist in our entire galaxy of 400 billion stars. And yet, the theory refused to die. Because the universe has a habit that scientists have learned to respect. If physics allows something to exist, the universe usually finds a way to build it. Somewhere out there, maybe in the Magellanic Clouds, maybe in our own galactic backyard, there is very likely a red star shining with stolen light. A star that is also a graveyard, a fusion engine wrapped around a gravitational one, two stellar lifetimes fused into a single point of light that, to our eyes, looks utterly unremarkable.